Today we are going to go back and talk about how to solve quadratics. So far, we have solved quadratics in two different ways. We can factor things, or we can take square roots. And I have an example of square roots. Like if we were going to solve x squared plus 2 equals 11, we would subtract 2 from both sides, and then we would take the square root of both sides, and we would get x equals plus or minus 3. Okay. An example of a factoring problem is if it were like x squared minus 3x minus 10 equals 0. We would factor this, x minus 5, x plus 2. We set those both equal to 0, and then we finish solving. So x equals 5 and x equals negative 2. Okay, so those should look familiar. That's what we've done so far. Now, coming back to this one. This one only works in special circumstances. It doesn't work when you have both an x and an x squared most of the time. We actually can force problems into a situation where we can use this method, and it's called completing the square. So let me just show you a couple examples before we move on. So this one we have right here. 25 equals x squared plus 14x plus 49. Now, normally we don't factor unless it's equal to 0, but just this one time, I want to show you what happens here. This thing right here factors into, we need numbers that multiply to 49 and add up to 14, so plus 7 and plus 7. And since they're the same, we can write this as 25 equals x plus 7 squared. Now, that was not something that we were able to do with this factor up here. It didn't work because those weren't the same. But with this one, it did. It was a perfect square. So now I can take the square root of both sides, and that's going to give me x plus 7, and the square root of 25, I introduced the square root, is plus or minus 5. And now I'm going to subtract 7 from both sides. And so that gives me x equals negative 7 plus or minus 5. Now, that's two different answers. Negative 7 plus 5 is negative 2, and negative 7 minus 5 is negative 12. Okay, so those are my two answers. Now, as you can see, those are really special types of problems that this will work for. Most problems it won't, but I have a couple more that it does work for, so I just want to show you these. So notice this, when you factor it, if you're looking for factors that multiply to 36 and add up to 12, well, it's 6 and 6. So we get 81 equals x plus 6 squared. We can take the square root of both sides, so we get x plus 6 equals plus or minus 9. Subtract 6 from both sides, so our answer is x equals negative 6 plus or minus 9. Those are two different answers. Negative 6 plus 9 is 3, and negative 6 minus 9 is negative 15. All right, one last one of these. We are looking for factors that multiply to 64 and add up to negative 16. So it's going to be x minus 8, x minus 8. So we get 9 equals x minus 8 squared. You introduce the square root, so we have plus or minus 3 equals x minus 8. We'll add 8 to both sides, so x is 8 plus or minus 3. And that gives us two different answers. I'm going to put them both up here. 8 plus 3 is 11, and 8 minus 3 is 5. Okay. Now, like I said, this doesn't always work. Okay. This was just some special cases because they factored nicely. But if they don't, we can force them into this form, and it's a method called completing the square. So we will investigate this in the next video.